So under spherical refracting surface, so whenever teach the derivation, first we teach the derivation. Before derivation, what all we tell? Refraction from rarer to denser medium at a convex spherical surface. What are the points you will stress before that? You will define principal axis and all that, isn't it? Correct? Though they have done in so they have done in 10th standard, but anyway, they would have done with respect to lens. So we are considering surface, convex surface. So convex surface, how do you distinguish between a convex surface and a concave surface? What I tell this, convex towards rarer medium. This is a convex surface. So this one will be rarer. Or this cave portion will be denser in the case of convex and the cave portion will be rarer in the case of concave. That way only I explained. Mu1, no, that convex, this is the convex portion. This convex portion will be facing the rarer medium. And you define pole, center of curvature and aperture. Okay. So I don't think these concepts will be tested. Anyway, we have to teach them. Now, one of the paper I saw, what are the assumptions in dealing with refraction at spherical surface? What are the assumptions? This is very, very important because we don't consider the object to be extended. The object is a point-sized object. So when we take the object, it is a point-sized object. It's a point-sized object. Okay. So when you consider it as a point-sized object and the rays are very close to the principal axis. The rays, the incident ray and the refracted ray are very close to the principal axis. And they make small angle. They make the incident ray, refracted ray make small angle. That's why you make tan alpha as alpha, tan beta as beta, isn't it? So unless we make this assumption, you can't, in the derivation, we can't do that. We do that, no? Tan alpha is equal to alpha, isn't it? Yes or no? Correct? Am I audible?
Yes, ma'am.
Yeah.
Yes,
So this assumption you have to teach them. The object consists only of a point lying on the principal axis. The aperture of spherical lens, aperture is very small. This equation holds good only for small lenses. Aperture is a size, effective diameter of the lens. The aperture is very small. And the incident and refracted ray make small angle with the principal axis so that sin I is equal to I and sin R is equal to R. So with this assumption, we start the derivation. So I'm not going to do the derivation. Okay. So when the image formed is real. So what do we get? We get this formula, isn't it? Mu1 by minus u plus mu2 by v is equal to mu2 minus mu1 by r. This is when refraction at a convex surface and the object is in the rarer medium. Then rarer to denser virtual. We don't do that, but do we get the same formula, different formula? Whether the image is real or virtual. Do you get any change in the thing or same? Whenever refraction occurs from rarer to denser medium, whether the image is real or virtual, you will get the same formula. Okay. So you may tell this to the students, whether the image is real or virtual. See, you are going to get the same formula. Okay. So this, sometimes they ask a question from the, from this equation. Mu1 by u plus this refraction at a surface. So they give all the values. Light from a point source in air falls on a convex spherical glass surface. Calculate position of the image when the light source is at 1 meter from the surface. So you know mu1 is 1 from air to glass. So mu2 is 1.5. R is plus 20 centimeter. R is this surface. So R will be plus. So the sign of R is very important. So if you consider a convex surface, this is a convex surface, isn't it? So for this, center of curvature will lie here. So R will be positive. And sign conventions are very important. How do you teach the sign convention? Hello? Which direction you take it as positive, teachers? Which direction? So distance are measured from the
X axis is a positive, plus X axis.
Plus X.
Like
Minus
how
X.
we will plot the graph, no, ma'am, the same way, ma'am. Here.
You will this Cartesian sign convention you follow? This is x, sir. This is minus x, y, minus y. Do you do that? But suppose if the object is, suppose you take a lens and the object is here. Can I take the object distance as positive? Object is here because it is along the plus x axis. Can I take? No, no. Object
mirror,
distance always you take it as negative because the criteria for sign convention is direction of incident ray is positive. What is that? Direction of incident ray is positive. So when you take a ray from here, object is here point sized, and the distance are measured from the pole of the spherical surface. We define this P as a pole of the spherical surface. So PO is the object distance. So now this distance is positive, isn't it? So if you consider this, PO is the object distance U, which is the positive direction. Light is starting from the object and it is striking the lens. So this is positive direction. PO is opposite to the direction of incident light. That is why PO is negative or U is negative. Okay, so this is the criteria, not plus axis or minus x axis. So in that case, so if you take this this Cartesian sign convention, then even in 10th standard you must have that this point, point would have read that object is always to the left of the lens or mirror. Object is to be kept only when the object is kept to the left side of the mirror. This convention I can hold good. Okay, but practically it is not possible. Object can be kept to the right of the lens or left of the lens. Okay, what is the criteria now? What is the criteria for sign convention? What is the criteria? Which direction is positive? Yes, which direction is positive? Which direction is positive?
Along incident ray direction.
Yeah. So the direction, suppose if you take a thin lens, okay, an object is here. So light is going to strike from the object to the lens. And we will measure distance from the optic center. So OA is minus U because the direction of incident light, I'm taking it as positive. So suppose image is formed here, the image A dash, B dash. So OA dash will be positive because OA dash, the distance is along the direction of incident light, this direction. So this you have to, this point you have to make it very clear. So refraction from denser to rarer medium at a convex refracting surface. So, so when the object is in denser medium, okay, so we follow the same, this one, Snell's law. From Snell's law, we derive it. I need not derive, no, teachers. So what do you expect the final formula to be? So this is the final formula, isn't it? So previously from rarer to denser, what is the formula? Rarer to denser, it was mu1 by minus U plus mu2 by V is equal to mu2 minus mu1 by R. This was the formula. This is rarer to denser, and exactly you have to change the subscript here. In place of mu2, you are having mu1. Okay, so having done this, then we have to do the lens maker formula. All this for all the other cases. So please go through this type of problem where we consider only refraction at the one spherical surface. Okay, and we go from refraction from spherical surface, we go to the lens. So now a lens has got how many foci? A lens has got how many foci? One or two? One or two? Please keep on interacting.
2, ma'am.
2. So it is F1 and F2. F1, F2. Can I take F1 as positive, F2 as negative for a convex lens? F2 negative. So this one is F1, F2 focal length. This one is F1. So if the curvature is same, suppose if the lens is equally curved, then we can take f2 to be equal to f1, that is f. Okay, for a biconvex lens, equal curvature. They have radius of curvature of the two surfaces the same. Then we take it as f. Then only we can take it as f. But according to sign convention, we take focal length of convex lens is always positive, though it has got two foci, one on the right hand side, another on the left hand side. Why it is always positive? So in this case, we can tell when the light is coming from left hand side, when the light is coming from the object at infinity on the left hand side of the lens, f is positive here. Okay, let us prove whether same thing appears. So now suppose light is coming from this side. Okay, then this f will be, can I take the focal length as negative? Can I take the focal length to be negative? Here also I will take only as positive. Why? Here also in this case also it is positive. This case also it is positive. So focal length of convex lens is always positive. Why? So here, according to sign convention, the direction of incident light, this direction is positive, isn't it? Correct? So focal length is positive. So according to this diagram, which direction is positive? This direction is positive, no? So this OF also will be positive, isn't it? Correct? Am I correct? Yes? Ramesh Babu sir, what happened today? Anuja, Aparna?
Ma'am, that means the object on the right side, ma'am.
Here object is on the right hand side. Any distant object on the right hand side. Rays are coming from the distant object. So after refraction, they all the ray meet at focus. That is only focus. No, this
Yes,
is focus. Okay.
Yes,
So in this case, this direction is positive,
yes,
isn't it? This direction is positive. So OF also positive. So when the object is towards the left of the lens, left to right is positive for me. This direction is positive and OF is positive. Okay. So similar.
Actually, here, ma'am, from left to right, right means is positive as per the sign. But
Yes.
right to left also we are considering positive means then which is negative, ma'am.
No, ma. We don't consider now. You are not supposed to consider this. Forget about the Cartesian sign convention now. Okay.
Okay, ma'am. Okay.
Now
ma'am.
don't fix that. This is plus x and this is minus. Don't fix at all. This
Okay,
holds
ma'am.
good only when the object is here.
When the object is incident on
to
the
the
lens,
left.
that side we are
Object can be
considering as
yeah.
positive.
Object can be to the right of the lens or left of the lens. No, can be, isn't it?
Okay. Yes,
So
ma'am.
you have to consider the direction of incident light as positive.
Positive. Yes, ma'am.
So if
Now
this is
it's
positive,
clear,
now
ma'am.
this distance is
This
positive.
distance also positive. Yes,
If this
ma'am.
direction is positive, now this direction is positive.
Yes, ma'am.
Okay. So here
Okay,
see,
ma'am.
now see here, which direction is positive? This direction is positive.
From
This
left to
direction
right
is positive.
is positive.
Ah,
Yes,
very
ma'am.
good. So now we are taking the, what is the focal length now? OF.
Ma'am,
O to
so
always distance.
ma'am, irrespective of the lens, do we consider a direction of incident light as positive?
Positive, yes. That is a criteria. Irrespective of the lens, irrespective of the position of the object, always consider what? Direction of incident light as positive. If you take in the case of concave lens, if you take in the case of concave lens, this direction is positive, isn't it? But what is the focus? Focus is here. So focal length is this distance. This distance is focal
So
length.
it is negative.
So it is negative. This is negative. So it may see that here the object is towards the left of the lens. Even if the object is towards the right of the lens, okay, then I will consider, I'll take another. So now, see here, now I'm considering the object, any distant object here, say a tree. Okay, light is coming from here. So it is going to diverge. It's a concave lens, isn't it? And this is the optic center. So now, so this is your F.
Okay.
So now which direction is positive for me? This direction is positive. Now that is the direction of incident light. Okay. So what is OF?
It's negative, ma'am.
Negative. No, you got my point?
Yes,
So here
ma'am.
afterwards, don't consider the Cartesian sign convention. That is also true. But only condition is if you consider Cartesian sign convention, this x minus x, this for 10th standard, they take it. The object, the first point, first line will be the object is always kept towards the, this is the origin means left of the origin. Object is always kept at the left of the origin. In that case, if you consider this the lens position, okay, object distance will be negative, correct? Left side negative, right side positive, that you should forget now. Okay. Now we are going to do the lens maker formula. Again, when lens maker formula, usually they ask lens maker formula. For 3 marks, they may ask. Okay. So now see here, all see the sign convention. What type of sign convention students are expected to write? All distances are measured from the optical center of the lens. Okay, distances are not measured from the object to the optic center. From where they are measured? From the optic center. All distance measured in the direction of incident light are taken as positive, where all distance measured in direction opposite to the direction of incident light are taken as negative. Okay. And for a convex lens, F is positive, and for a concave lens, F is negative. So sign convention is important, and assumption also important. In the case of lens, the lens is thin. The lens is thin, so the distance measured from the pole of its surface can be taken to be equal to, see here, in the case of convex surface, this is the pole. Suppose this is a surface, convex surface is this. This is convex surface. Do you understand the difference between convex surface and a lens? A lens is bounded by 2 convex surfaces, convex lens. Okay. So now the lens, see, we are not going to measure distance from the, this is P1 and this is P2, 2 poles. A lens has got 2 spherical surface, 2 poles. So we'll assume that the lens is very thin, that P1 and P2 are very close. So we'll assume that the distance will be measured from the center of the lens, optic center of the lens. So when we switch over from refraction from spherical surface to lens, we'll assume that lens is thin. Lens is so thin that distance measured from the pole of the surface can be taken as equal to distance measured from the optical center. Correct? Anuja ma'am, correct? We teach them, isn't it?
Yes.
Yes. Yes. So the object consists only of a point lying on the principal axis of the lens. So even lens maker formula, we are going to consider object as a point. We are going to consider as a point. Okay. So now you know that when we teach the lens maker formula, we take OA as the object. So in the absence of the second surface, the image will be I1. The image will be I1. But before it forms the image, it could travel along BI1. It undergoes second refraction, and finally the image is formed at I. So we consider this as object distance U, and image distance for first refraction at the surface XP1Y is V1, and image distance for the second refraction will be P2I. I is the final image. Yeah, very good. I1 act as a virtual object for the second surface, that they should tell. I1 act as a virtual object for the second surface. So we are going to just use the refraction. So I've drawn it separately. See, these are the book diagram I've taken. So this is the refraction at the surface. And see here, when it is entering, this direction it is entering, isn't it? Entering the next surface. This is the next surface. So actually this is this convex lens is this part. So first, when we have considered only refraction at a convex surface from radial tensor, I1 is a first image. So now the ray of light which is entering the second surface, in the diagram, the ray, I'm not bringing from the principal axis, no? Correct? In the ray, already it has undergone refraction at the first surface. So on the ray, the second surface refraction. Correct?
So for the second refracting surface.
Second refracting surface. So incident ray is like this. So it has undergone refraction at the first surface and it is entering the second surface. So finally image is formed here. So when the students can explain பண்ணும்போது, you can draw this diagram. But suppose if the students are getting this 3 mark, if they draw this diagram, it is enough. But ana students can explain பண்ணும்போது, you have to draw these 2 diagrams. Do you do that? We separately teach them. But lens maker formula derive பண்ணும்போது, இந்த diagramமோ காமிக்கணும், இந்த diagramமோ காமிக்கணும். ஏன்னா இது bookல இருக்கு. And it's very important. ஆனா இந்த angle வந்து பண்ணணுமான்னு தெரியும். Angle பண்ணும்போது, see the angle we mark when we are deriving the expression, no? Refraction at a spherical surface. Alpha, beta, gamma, even R1 la பண்ணும். இப்போ இந்த I2 எப்படி வருதுன்னு உங்களுக்கு தெரியணும். I2. Okay va? Okay. So now we write expression. So this is for the first refraction. Mu1 by minus u plus mu2 by v1 is equal to mu2 minus mu1 by r1. Now we bring the refraction. So this should be r1. That is radius of curvature of this surface is r1. For the second refraction, it is mu2. See, for second refraction, subscript மாத்தணும். 1 in the place, 2 போடணும். Correct? அப்ப mu2, the object distance for the second surface is v1. Correct? Am I correct?
Yes, ma'am.
Yeah, v1. So, இங்க என்ன வரும்? Mu minus mu2 by v1 plus mu1 by final image is formed at v. And previously we got it as mu2 minus mu1. Now, இங்க mu1 minus mu2 by r2. So, இத convenient mu2 minus mu1 by minus r2 மாத்திக்கினா, when you add the 2 equation, you will get the lens maker formula. Okay, va? So now we are getting 1 by f is equal to, actually this is the formula. This is the formula and we know that 1 by v minus 1 by u is equal to 1 by f. So 1 by f, directly we can write 1 by f as power mu2 by mu1. This is the formula. When only when the case when the surrounding medium is air, I can write mu2 as mu and this will be mu minus 1. So what do you think the focal length of the lens depend? Focal length will depend on?
Yes.
Does it depend on object distance, image distance? Does it depend on object distance and image distance? Because you are getting 1 by v minus 1 by u is equal to 1 by f. Does it depend on that? Yes or no, teachers? Huh?
It depends on radius of curvature and
refractive index of the lens as well as refractive index of the medium. It depends only on these factors. R1, radius of curvature of the surfaces, refractive index of the lens as well as refractive index of the medium. Okay. Okay, shall we do this problem? A double convex lens made of refractive index 1.6 has its both surface equal radius of curvature. So let us, where it is kept? Is it mentioned? It is not mentioned. So we'll consider mu1 to be 1. Mu1 to be 1. So mu2 is equal to 1.6. So I can very well write the formula as what? 1 by f is equal to mu minus 1 into 1 by radius of curvature. What I can take R1 and R2. It is given radius of curvature is 30 centimeter. So R1, can I take it as plus R? R2 will be what? Minus R. Correct? Am I correct? So otherwise it will this will get cancelled, no? If you take no R1 is 30 centimeter, R2 is equal to 30. If you don't apply sign convention, na, very dangerous. Correct? So you have to apply sign convention. R1 as plus R, the students tend to make mistake, so you have to tell them. So 1 by R minus of 1 by R. So plus 1 by R. So my this one will be mu minus 1 into 2 by R. And this one is 1 by v minus 1 by u can write. Because in this problem, it is asked, see here, a double convex lens made of refractive index 1.6 as its both surface of equal radius of curvature. So R1 is R, R2 is minus R. Equal, but the sign is different. Signs are opposite. An object of 5 centimeter height is placed at a distance of 12.5. So what is object distance? What is object distance? Teachers? It is minus 12.5. Okay. So 1.6 minus 1 will be 0.6 into 2 divided by R is 30. So 1.2 by 30 will be 1 by V minus 1 by U. So 1 by V is 1.2 by 30 plus 1 by U. U is negative. U is how much? Minus 12.5. So minus 1 by 12.5. So you have to simplify this. So can anybody tell the answer? 1.2 by 30 minus 1 by 12.5. So I can write this as 12 by 300. And this is 10 by 125. 4 by 100 minus 2 by
Point
4.
huh?
plus 0.04.
How much?
Minus 0.04 I'm getting now.
Image distance. 4 minus 8. Actually, I'm getting minus 4 by 100. Minus 4 by 100. That is 1 by F. Correct only. You are getting correct only. But sorry, 1 by V. So V will be minus 100 by 4, which is minus 25 centimeter. Am I correct?
Yes, ma'am. Yes,
V
ma'am.
is, so it forms a. So what is the nature? V is negative na?
It's in the side of the object.
Same side as the object, so it is virtual. It is virtual. Okay. So you can get the magnification M is equal to V by U, which is H dash by H. So you can get H dashed. So H dash should be positive here because it is virtual. Okay. So tell the children when you are doing problem now, they should be very careful with the sign convention. Okay. A converging lens has a focal length of 20 centimeter in air. It is made up of a material of refractive index 1.6. If it is immersed in a liquid of refractive index 1.3, calculate its new focal length. So here, how will you do this problem? You will write 1 by 20, correct? It is made up of material of refractive index in air. So you have to write the formula for focal length in air. Focal length in air is mu minus 1. So you can write 1 by F. First formula is 1 by F is mu minus 1 into the. Ask the children to write like this because same 2 by R. Can I write like this 2 by R? Because 1 by F is mu minus 1 into 1 by R1 minus 1 by R2. R1 is plus R and R2 is minus R. Correct? So this portion will be 2 by R. So 1 by 20 is mu minus 1 into 2 by R. Mu is 1.6 minus 0.6 into 2 by R. If it is immersed, second equation 1 by F. So now 1 by F dash is equal to, here it is 1.6. Now the equation is mu 2 by mu 1. Correct? Mu 2 by mu 1. This is actual formula. 1.6 by 1.3 minus 1 into 2 by R. So you put this equation as 1. This is 2. Okay. Sorry, this equation 1. This is 1.2. 1 by 20 is 1.2 by R. So R you can calculate from this and substitute here. So what is R from first equation? What is R? R is equal to 32, na? Correct? Am I correct? From this equation, R is 32, no? What Aparna? Hello?
Yes, ma'am.
Yes, R is equal to 32, no? From this equation.
Yeah.
So you substitute here. So here 1 by F dash would be, yes?
R is equal to 2.4, no, ma'am.
2.4, 24.
Yes, ma'am.
24. So 1.6 minus 1.3 by 1.3 into 2 by 24. So 1 by f dash will be 0.3 by 1.3 into 1 by 12. So f dash is, so if I multiply 12 into 1.3 by 0.3. So that's all. So 0.3, so 120 into 1.3 by 3. So 40 into 1.3. So 40 into 1.3 will be my f dash. Okay, focal length is increasing. See, previously in air it was 20 centimeter. Now 40 into 1.3 will be how much? 1.3 into 4. 13 into 4. 52, no? Are you getting the answer as 52 centimeter? F dash is 52. So it is behaving like a convex lens. I'm getting the answer as plus 52, but focal length has increased when it is immersed in a liquid of refractive index 1.3. So this also if the students can do. So all this principal focus, lens formula. Now we derive thin lens formula. Okay. Linear magnification. H dash by H is equal to V by U. Okay. And combination, mostly questions are, I've seen many questions, board questions based on combination. This derivation is very important. Please tell the children this derivation they have to learn. So even see they have derived the expression for the effective focal length of combination of two thin lenses. So they will draw the diagram. So here, similar to lens maker formula, in the absence of lens L2, the image is formed at I dash. So I dash, as Anuja said, I dash will act as a what? Object. What type of object? I dash is going to act as a virtual object for the second lens. So first formula is this 1 by V dash minus 1 by U is 1 by F1. The second formula, second lens, the final image is formed at V. So 1 by V minus 1 by V dash is equal to 1 by F2. So if you add the two, I will get 1 by V minus 1 by U as this. So 1 by V minus 1 by U is 1 by F. So 1 by F. All the steps are important. This may appear, say what the children do is they miss the intermediate step. So if suppose if they give this as a 3-mark question, can you tell me the marking scheme for this? Teachers, please interact. If suppose if the question is derive an expression for effective focal length of two convex lenses of focal length F1 and F2 in contact. In contact only there, out of contact, not in syllabus.
Diagram 1 mark.
Diagram 1 mark. You're going to give diagram 1 mark. Then
Half mark.
first refraction half mark.
Second 53 equation another half mark.
Then 2 marks. Again here half mark.
Final
And then
equation
combining combining this half mark. So 3 marks. 3 mark. Yes. So sometime if they don't write this median any step, no, this 1 by F1 is 1 by V minus 1 by U. Directly if they write now this step mark, they will lose. They will lose the step mark. And do you insist the children to draw the arrow mark for the diagram? Definitely. Yes. For the ray diagram, arrow marks are very, very important. Okay.
Diagram, ma'am, diagram explanation any mark is there?
No need for any explanation at all for diagram or explanation. Okay. Sometimes they don't ask them to write paragraph and paragraph, teachers. Okay. So if they write L1, L2, object distance, U, V dash V, everything is given in the diagram itself, isn't it? So they see for the correctness of the diagram. That's all. They don't see the explanation for the diagram at all. In that way, you can ask the children to save their time. Unnecessarily, please, all this not at all necessary. Yes. No, not at all required.
They no need to write it in.
Sometimes see here, if they ask you, no, see, sometimes they don't even give half mark for this. They give half mark for this because 1 by F is not asked, no. Only F is asked, isn't it? So they should arrive at this equation.
Yes, ma'am. Final equation.
Final equation. What is the question? Find the effective focal length. So if they leave like this, they won't give mark. Mark is not given for this step. This step, This is what they're asking. They're asking only if the effective focal length. So they should finish with this. Otherwise, the children will, the child will lose half mark. Ask the students to read the question properly. So they should conclude the final step for the answer with what is expected in the question. Okay, teachers.
Okay, ma'am.
Yeah. So suppose if they want for, but sometimes they ask this. If one is convex and another concave, find the effective focal length of the combination. So 1 by f, if they very well know 1 by f is 1 by f1 minus 1 by f2. So if they write this one, they won't give mark. They have to write this. F is equal to f1 f2 by f2 minus f1 because that is what expected.
Okay, ma'am.
Yeah. All this we teach them. Okay. Let us see. One more question. The surface of the sunglasses are curved. Yet their power may be 0. Why? So you must have seen no sunglasses or goggles. They are curved. They are curved like this. So they may have, see, for a lens 2 surface. So this factor becomes 2 by r, isn't it? 1 by r1 minus 1 by r2 becomes 2 by r. Whereas sunglasses, it may have 2 lenses.
Ma'am, I can't hear you, ma'am.
Hello, am I audible?
No,
Okay,
ma'am.
ma'am.
In between, your voice got cut.
Now, am I audible?
Yes, ma'am.
Audible,
Ma'am,
ma'am. Audible.
Not visible, ma'am.
Because my internet connection is unstable, is coming. My power also gone. Okay, so okay, power is there. So now I'll share. I'll share my screen, see whether it is visible. Is visible?
Yes, ma'am. Now it's visible, ma'am.
yes, ma'am.
Now visible.
Okay, now it is visible. My voice also clear, isn't it?
Yes, ma'am.
Ma'am,
Yeah.
yes.
Okay. So R1, R2 both are same. R1 is equal to plus R. R2 is also plus R. So in that case, 1 by R1 minus 1 by R2 is 0 here, isn't it? So power is 0. By goggles, even though they are curved, not flat. Flat surface, F is infinity for a plane surface. Suppose for a plain glass. Huh?
For this, so they have taken 2 glasses, ma'am. Convex.
Two curved surface. It's not lens. 2 curved surface equally curved. So R1 and R2 are positive. Both are positive. So power is 0. Focal length is infinite. For a plane, it acts as a plain glass. Okay, plain glass. But it will appear as curved. Appear as a plain glass. Okay. You don't see, no, sunglasses are curved. But
Yes,
they're
ma'am.
not curved like this. They are curved. Okay. By calculate the position of the image of an object when it is focus. Focus of a convex lens, focus of a concave lens. What do you think? In both the cases, image is at infinity, isn't it? So you use the formula 1 by f minus 1 by f is equal to 0. So 1 by v is 0. So v is infinity. Students will make mistake in this. 1 by f, 1 by v they will calculate, but they won't write v as infinity. We know all this. As teachers, we know, but children, they will make mistake. Even then, when you calculate the image distance, no, they will give the answer for 1 by v, isn't it? Most of the children you must see. Correct. So 1 by v, if they give it as 1 by 30 now, they will calculate this 1 by 30 and then they will write it as 30. 1 by 30 is 0.03. They should not do that. So you should instruct the children. Children is 1 by v, calculate the reciprocal and do it and give the final answer. Okay, this is also often asked question. The refractive index of the material of a concave lens is n. It is immersed in a medium of refractive index n1. Okay, immersed in a medium of refractive index n1. A parallel beam of light is incident on the lens. Trace the path of emergent ray in each of the following. N1 and N1 is equal to n. So now concave lens is behaving like a converging lens. How it is possible? See, you know that lens maker formula, no? 1 by f is equal to what? Here in this case, it is n1 by n minus 1. Am I right? In the case of concave lens, in the case of convex lens, I get this as 2 by r. Concave lens, what will I get? Huh? This is a lens maker formula, correct? What is R1 for? R1 is minus R. R2 is plus R for concave lens, correct? R1 is minus R. R2 is plus R. So I will get this particular thing. Refractive index lens is 1 and this is n. Minus 1. I will get minus 2 by R. Am I correct? Okay, va? Yes. So now F will be negative. So F is negative if n1 is greater than n, correct? Am I correct? Because I will get the formula n1 minus n by, the formula here will be 1 by f is equal to n1 minus n by n into minus 2 by r. Am I correct? I am deriving from this because in the problem it is given that n is a refractive index of the medium. Oh, correct. So this is n. Okay. So inge vandu n, this is n, this is n1. N is the refractive index of medium is n1 and refractive index n2 is n. N2 is n. So 1 by f is n minus n1 by n1 into minus 2 by r. So n is the glass. So now n is more than n1 now. What of f? Tell me, teachers. Please tell me. Get yourself please involved because I'm not able to judge whether my connection is there or not, because that's why I'm asking you to interact. What is the sign of? Yes, yes, teachers. Am I audible?
Yes,
Am I
ma'am.
audible? Yeah. Get this for a concave lens. I'm writing 1 by r1 minus 1 by r2 is minus 2 by r. Here the problem is the convex lens, concave. Here it is concave lens. The refractive index is n. It is kept in a medium n1. So if n1 is greater than n, it behaves like a convex lens. Why? Can you tell me? I have derived. Now I know this is a lens maker formula. And for a concave lens, R1 is equal to R2, R1 is plus R, R1 is minus R, R1 is minus R. Because, why minus R? Because the ratio of curvature for this will be here. So from optic center, OC will be minus for the surface. Plus for the surface, R2. R2 will be positive. Are you able to understand? Am I correct? Yes or no? Do you have any problem with this? Huh?
No, ma'am.
Correct?
Yes, ma'am.
So just you have to tell me why this convex lens is behaving now. F is becoming positive. No, how F is becoming positive here? Because see here, n1 is greater than n. N minus n1 will be positive or negative. N1 is greater than, see, n. For example, suppose this is 1.5. N is 1.5. N is 1.5. N1, say, let me take N1 as 1.7. So what will be N minus N1? N is 1.5. Minus 0.2. No. So here this is minus. Already there is a minus. So I am getting the focal length is positive. That is why a concave lens is able to converge. Purijda?
Yes, ma'am.
Okay. So concave lens can act as a convex lens when? When can concave lens act as a convex lens? இப்போ நீ convex lens வந்து 1.5 refractive index na, suppose if you immerse the concave lens carbon disulfide la நீ போட்டியானா, if you immerse in carbon disulfide has a refractive index 1.7. So this lens will act as a what type of lens? Converging or diverging? Yes, sir. Ramesh Babu, sir.
Converging.
Converging. Converging. புரிஞ்சுதா? இப்போ நான் என்ன பண்றேன்னா n1 is less. இது 1.5. n is 1.5. n1 is only 1. It is in air. அப்ப என்ன ஆகும்? What will be n minus n1? It will be positive. No. n minus n1 will be positive. So already there is a negative. So this is going to behave like a concave lens only. Concave lens. In the case another lens is acting as a plain glass. So one see now இப்போ ஒரு லென்ஸை நான் கிளிசரின்ல போட்டேன்னு வெச்சுக்கோங்களேன். ஒரு லென்ஸை நான் கிளிசரின்ல போடுறேன். கிளிசரினுக்கு 1.5 தான். The length 1.5. I think you must have done this activity, no? கிளிசரின்ல நான் கிளாஸ் பிளேட் போட்டேன்னு வெச்சுக்கேன். ஒரு லென்ஸ் கிளிசரினோட ரிஃப்ராக்டிவ் இண்டெக்ஸ் 1.5, கிளாஸோட ரிஃப்ராக்டிவ் இண்டெக்ஸ் 1.5. அந்த கிளாஸ் டிஸப்பியர் ஆயிடும். ஏன்னா ரிஃப்ராக்ஷனே there is no refraction. So refraction only make the lenses visible, na?
Yes.
Okay, in water. So refraction is nadakadu. So here when n is equal to n1, n minus n1, go in the 0 by. So 1 by f becomes 0. So f is equal to infinity in that case. Infinity na f is infinite, it act like a glass plate, plain glass plate. So no refraction will take place. So when refractive index of the lens become equal to refractive of the medium, no refraction will occur. So this one we have done for convex lens. Same way we can also try it for concave convex lens. So convex lens, when it will behave like a diverging lens, convex lens, it is possible for it to, suppose convex lens, this is also possible. When suppose the refractive index is n. When n2 is greater than n1, refractive index of the medium is greater than the refractive index of the lens, it will behave like a diverging lens.
Diverging.
Okay. So following data was recorded for values of object distance and corresponding value of image distance in the study of real image. One of the observation is incorrect. Identify. In the observation, we practical correct observation. In the observation, இது focal length 5 diopter. Sorry, power 5 diopter, focal length 20 centimeter. இப்போ எந்த observation கரெக்ட்டா தப்பா இருக்கு? So object distance இது between f and 2f, so beyond 2f. இதுவும் between f and 2f. கரெக்ட்டா? 20 centimeter between f and 2f, beyond 2f, 40 க்கு மேல வருது. இதுவும் between f and 2f. இது என்ன? கரெக்ட்டா?
Less value. Yes.
Less than 40. It is less than 40. So in the die wrong. This observation is wrong. All the other observations are beyond 2f. So it is between 2f. So this observation is wrong. Yeah. So when does the convex lens behave like a concave lens? Already discussed this. Okay. When the convex lens is held in a transient medium of index greater than the refractive index of the lens material, it would behave like a concave lens. Now, this also I discussed. The lens immersed in a transparent liquid become invisible. Under what condition does it happen? When does it happen? The lens disappear. When it is immersed in a are equal. Medium or refractive index, so lens or refractive index, so equal are the, it will disappear. Why does it disappear? Refraction in nadakadu. Okay.
Yes, ma'am.
Yeah. On the image object on its axis, if the lens is placed with its face first, will the position of the image change? In R1 R2 na matram position marudhu. Change aguma maradu. It won't change. It won't change when the lens equal focal length illa. Ipdi one irukku, inga opdi one irukku. So R1 R2 different ஆ இருக்கு. இது இந்த ஃபேஸோட இது வந்து R1, இங்க R2. இப்போ நான் ரிவர்ஸ் பண்றேன், இப்படி and இப்படி. சோ இத நான் ரெட்ல வச்சுக்கிறேன். சோ இங்க நான் ஆப்ஜெக்ட் வைக்கிறேன். இப்போ நான் ஃபேஸ் ரிவர்ஸ் பண்ணி ஆப்ஜெக்ட் வைக்கிறேன். I am keeping to the so now face reverse பண்ணிருக்கேன். Will the position of the image change ஆகுமா? First case வந்து 1 by R1 minus 1 by R2. Correct? Second caseல வந்து 1 by R2 minus 1 by R1 வரும். அவ்வளவுதான். So R1, R2, as long as you're not changing the lens, position of the image or the focal length will not, position of the image will not change.
But the focus is depends on R and the refractive.
Yes. So the ratio of curvature both the surface of a lens are equal. R1 is equal to R2, so 2 by R. How will its focal length and power change if one of the surface of the lens is made plane? Okay, wow. So in the case, first case, we write 1 by F is equal to mu minus 1 into 2 by R. One surface plane, R2 is infinity. R2 is not 0, please remember, R2 is infinity for plane surface. So R1 is plus R. So 1 by F dash is mu minus 1 into 1 by R. So mu minus 1 by R. So what is the relation between F dash and F? Are you getting F dash is 2F? Correct?
Yes, ma'am.
F dash is 2F. Focal length becomes twice.
Right.
Power becomes half.
Oh. Yes, ma'am.
Within a glass slab, a double convex air bubble is formed. How would the air bubble behave? So glass bubble குள்ள glass slab குள்ள ஒரு double convex ஒரு air bubble இப்படி இருக்கு. Okay, this is air bubble. Okay, this is glass. Air bubble will behave like a convex lens or concave lens. Very nice question, isn't it? Air bubble is a lens. So lens is held in a medium and the higher refractive index. Air bubble oda refractive index வந்து 1. Whereas இதோட refractive index 1.5. Will it behave like a convex lens or a concave lens? இப்பதானே டிஸ்கஸ் பண்ணோம். இது lens. Air bubble is acting as a lens. Correct? Sometimes air bubble is a lens. Even a liquid drop will behave like a lens. நீங்க அந்த எக்ஸ்பெரிமெண்ட் பண்ணி காமிச்சிருக்கீங்களா? I used to do. ஒரு சின்ன drop, water dropல, through water drop, if you see the object now, the object will get magnified. பாத்திருக்கீங்களா? Water droplet. Through the water droplet, if you see any object now, it will be magnified. Okay, let us come back to this question. This air bubble will behave like a convex or concave? Glass slab குள்ள imagine inside glass slab ஒரு air trap ஆயிருக்கு, air bubble trap ஆயிருக்கு. Will it behave like a concave lens? Good. Enna air bubble oda refractive less than this glass slab here. So it will behave like a concave lens. Yes. Why does a convex lens? He is asking question now. Why does convex mu is equal to 1.5 behave as a diverging lens when immersed in a carbon disulfide? Why it is behaving?
Because the refractive index mu is greater than
அப்போ வந்து நீ lens maker formula எழுதணும். ஓகேவா? So it is n2 by n1 minus 1 into 2 by r. This is a formula. So when n2 is a refractive index of the glass lens. When n2 is less than n1. What is n2? N2 is 1.5. N1 is 1.65. So here n2 minus n1 will become negative. That is the reason. So a focal length becomes negative. So you have to, children should write the formula because they are asking the reason. Already it is given that it is immersed. They are giving, they are telling that it is behaving like a diverging lens. Why? You have to, the children should write the formula N1 will become negative. F is negative. F will become negative. Okay, wow.
Yes, ma'am.
Okay, this also I like this. So often asked question. So AB represent a lens with is this convex or concave? If lens remove பண்ணிட்டானா it is converging here. It is a converging source. So lens இல்லன்னு வெச்சுக்கோங்களேன். Lens இல்லனா it is going to converge here. Okay, இங்க converge ஆகிறது. இப்ப lens நான் introduce பண்ண உடனே point of convergence வந்து shift ஆகுது. இங்க shift ஆகுது. அப்பனா in the lens AB, what type of lens it is? Convex or concave? That's the question.
Concave, ma'am.
Yeah, concave. இது வந்து ஏற்கனவே நம்ம என்ன சொல்லிருப்போம் ஸ்டூடெண்ட்ஸ் கிட்ட என்ன டீச் பண்ணிருப்போம்னா இத மாதிரி டீச் பண்ணிருப்போம் a parallel beam of light converge. Okay, converge at a point. ஆனா இங்க ஏற்கனவே it is a converging beam. கரெக்ட்டா? இது வந்து converging beam. இந்த beam வந்து converging beam. இந்த converging beam நடுவுல நான் வந்து convex lens வெச்சேன்னா என்ன ஆகும்? திருப்பியும் இந்த point of convergence, okay, the beam will become more convergence. இங்க வந்துரும். So இது வந்து ஆனா இங்க வந்து என்ன ஆகுது? இந்த கேஸ்ல என்ன ஆகுது? It is moving away from the original converging position. So the incident beam has converged here. The lens has made the beam converge at a point away from the lens. That is possible only when the thing is concave. The concave ஆலதான் இது முடியும். Concave இருந்தாதான் அந்த lens a little diverging பண்ணிட்டு the rays will get diverged and the diverging point is shifted away from the original. The part of the rays, the convergence, the point of convergence shift towards the right. Apana the concave lens. Okay. This is also a very important question. Diverging lenses cut into two identical parts. What is the focal length of each part? இதோட focal length f, concave lens ஓட focal length f. இப்போ நான் அதை கட் பண்றேன். அது 2f ஆகும். What do you say?
One side
Hello?
will be parallel, ma'am. That is plane mirror. One side plane mirror R value is infinity. So that focal length becomes 2f, no, ma'am. Just now we are
Yeah. Yes. நம்ம பண்ணி பாப்போம். இங்க வந்து n-1. For a concave lens வந்து concave lens எடுத்துட்டா இது -2/r. கரெக்ட்டா? Concave lens. இப்போ இந்த பார்ட்டுக்கு மட்டும் we have to calculate only for this part. கரெக்ட்டா? இப்போ கட் பண்ணிட்டேன் நான். இந்த லென்ஸ் வந்து கட் பண்ணியாச்சு. இந்த போர்ஷன் வந்து கட் பண்ணியாச்சு. இந்த போர்ஷன் is not there. So 1/f1 எடுத்துப்போம் நம்ம. 1/f dash. For the this one has been removed. So it is n-1. So in the portion வந்து -r, -1/r. So the plane portion வந்து 0. So on the r2 portion இருக்காது. So 1/r1 -1/r2. Here I am writing it as -2/r because r1 is -r, r2 is also -r. இங்க 1/r1, r1 is r2 is, what is r2? R2 is infinity in this case. The plane இருக்கும்போது. So plane, in the plane surface, radius of curvature is infinity. So -1/r. So if you solve this now, so this will be -n-1 into r. This will be the equation. So what is f dash by f? The divide panna f dash by f, I will get it as 2. So f dash will be 2f. Twice. So now what is the focal length of each part is 2f. This holds good even for convex lens. If the lens is cut like this now, the focal length of each part will be 2f. You can even prove by combination. Suppose ஒரு லென்ஸே நான் வந்து என்ன பண்ணலாம், டிவைட் பண்ணிட்டு, so you know that 1/f1 plus 1/f2 is 1/f. Correcta? So 1/f1 is 2f. So I will get it as 1/f. 1/2f plus 1/2f is 1/f. So draw a plot of variation of power of a lens with wavelength of incident light. How do you get this? Power with wavelength. See, 1 by f, the lens maker formula, 1 by f is power, which is equal to mu minus 1 into 2 by r for a convex lens. For a concave lens, minus 2. So how do you relate? See, I have a form index and focal length, but you have to the variation of power is refractive index length.
Ma'am, your screen is not visible, ma'am.
Abdiya.
Yes, ma'am.
Okay. Now I'll see. Now is it visible?
Yes, ma'am.
Yeah. Now the power 1 by f is equal to power, which is mu minus 1 into 2 by r. This is for a convex lens. For a concave lens, what will I get? For a concave lens, what will I get?
Minus, ma'am.
Minus 2 by r. Now the question is, draw a plot of variation of power of a lens with a wavelength. So how will you solve this? There is no wavelength factor here, na? Is there any relation between refractive index of the lens and wavelength of light? Is there any relation?
No, ma'am.
Nova. Refractive index.
C lambda.
Refractive index mu is inversely proportional to lambda.
Yes, ma'am.
Okay. So lambda of the lens for red color, okay, is less than, sorry, mu r, that is refractive index of the lens for red color is less than refractive index of the lens for violet color. So that means refractive index of the lens is inversely proportional to lambda. Okay, wow. Refractive index of the medium is a function of wavelength. So power is directly proportional to refractive index. So can I write the relation between power and wavelength? Power is directly proportional to refractive index. Refractive index is inversely proportional to wavelength. What is the relation between power and refractive index now?
Their power also inversely proportional to wavelength.
Good. Power is inversely proportional to lambda. So this is the graph. So any inverse relation, you will get this is a hyperbola or hyperbola, isn't it? You will get a curve like this. Okay. Yes. So this is very important question.
Yes, ma'am.
So this one at 10th standard, you must have taught to the students, isn't it? I'm covering one part of 50% of the lens like this with a black paper. Will you get a full image or half the image? Will you get full image?
Yes, ma'am.
Yes. But what is the difference between the image formed by full lens and a half lens like this? Half is covered with a black paper. What is there? Definitely the image brightness will change, isn't it? Because this one is opaque. This part of the lens is made opaque. So less number of light from the object will undergo refraction. So the image, brightness of the image will be less. But full image will be formed. Okay. So now let me see whether I can discuss some question in the optical instrument. So this diagram tells us about angle subtended the eye, isn't it? So what is the function of the optical instrument? Like a telescope. Suppose you are viewing through a naked eye, we will not be able to see the two stars separately. Are you able to see the slide?
Yes,
but when you see through the optical instrument like telescope, these two stars will be visible. Why? Because they appear as well separated. It produces angular magnification. This theta subtended at the eye, when you view the stars through an optical instrument will be bigger. So the angle subtended at the eye is very important when you want to view two close objects as separate. Okay. So we learned simple microscope. I'm not going to do it in detail. This is a diagram of simple microscope, and the magnification formula they should know. The derivation also they should know. This is what is T by F, and you can go through the derivation if you want. And compound microscope. So what is the difference between the construction and working of compound microscope and telescope? It was one board question. What is the difference between the construction? Compound microscope, the objective and eyepiece, both the focal length should be small, isn't it? Focal length of objective, focal length of eyepiece, both must be small. Whereas in the case of telescope, objective should be large. Aperture of objective should be large. Why the aperture size should be large? Very important question, no? You must have seen all the astronomical telescope, the objective size is very large. Why? Eyepiece, of course, eyepiece always for all the optical instrument, eyepiece size should be small so that it can fit into our eye. Eyepiece size should not exceed our eye aperture, slightly more. So, why telescope objective size should be more? To have a large light gathering power, we are receiving light from a source which is very, very far away. Unless the aperture size is more. See here, this is a telescope, astronomical telescope. So the aperture size should be large in order that can collect large number of rays. You have a light gathering power. Okay. And this we call it as normal adjustment. Why normal? What is draw ray diagram of an astronomical telescope in normal adjustment. The normal adjustment for telescope object is always at infinity, so you take parallel rays. Okay, but when the image is also formed at infinity, object and image both are at infinity. Okay, then only it is called as normal adjustment. Am I audible, teachers? Am I audible?
Yes, ma'am.
Yes, ma'am.
So in normal adjustment, what is the length of the telescope? Length of the telescope is the distance between the objective and eyepiece. What is the length of the telescope in normal adjustment? So object at infinity, image is formed at F4. And this serves as the object for the eyepiece. So for the eyepiece, object is at and F4 and Fe coincide. Image is formed at infinity now. The eyepiece object should be kept at its focus. So F4 and Fe are both the same plane. Same plane I can say. So this is F4, this is Fe. C1, B is F4. C2, B is Fe. So what is the length of the telescope? What is the length? What is the length, teachers? Distance between the objective lens and eye lens. Suppose if you want your children to construct a telescope, okay, you can construct a telescope. No, you can have two tubes, correct? This is objective, side piece. So in order to view the image clearly, what should be the length? This is the length of the telescope. This is objective. What should be the length for normal adjustment? F4 plus Fe, isn't it? What, Anuja, Aparna, Ramesh Babu sir?
Yes, ma'am.
F4 plus Fe. And magnification is F4 by Fe. That's why sometimes the board, they ask this question. Why the focal length of objective should be more? Why the aperture of the objective should be more? Why should we have large, why should you select a lens of larger focal length for objective? Why should you select? Because the focal length magnification is F4 by Fe. And there is a minus sign, no? What is the significance of minus sign? Why I am getting a minus sign here? Why I am getting a minus sign? Is it inverted or erect? Image. Inverted. But see, when I'm saying seeing an astronomical object like planets or moon or any other star, doesn't matter whether they are inverted or erect, isn't it? Whereas when you use as a binocular, you should have some erecting lens. Okay, so when you view a match through binocular, I don't want the players to be seen here inverted. So in between the objective and eyepiece, they will have another lens. They are called inverting lens. So this is a different position. So what is the difference between this diagram and the previous diagram? What is the difference between this diagram and this diagram?
The image is formed at least distance within.
Yeah. Image is formed at D here. Okay. So you can go through these problems. I will send you this. So in Prism, I want to do some problem in Prism, repeatedly asked question. So whenever they ask Prism, derivation of Prism formula, ask what they forget to do is they don't draw the diagram. This diagram is very important. Okay.
In this graph for teachers, you can see for the same D value. So if you can just use my cursor, I know if you're able to see my cursor on the screen, right?
No, I will see. I will just.
Thank you. Yeah. See, if you see in the graph for the same value of deviation, you have two values of I. Okay, I1 and I2. If you see, the D value for both I1 and I2 are the same. Do you realize that?
Yes, ma'am.
Why is it the same? Why is it the same? Why do you think it is the same? How do you explain? That's a what question. How do you explain that there can be two angles of incidence for which the angle of deviation will be the same? Justify or explain. So how do you explain is, do you know the equation when you derive the equation, no, refraction equation of a prism? You have that equation which says D is equal to, ma'am has come to that equation correctly. Equation number 3, D is equal to I1 plus I2 minus A, right? And if you rewrite that equation, it will be A plus D is equal to I1 plus I2, right?
Yes, ma'am.
Right? Now this A for a prism is a constant. Will you agree? If I take a particular prism, it will have a particular angle.
Yes.
That cannot be changed. Right? Now I'm saying D is also same for I1 and I2. So A plus D is a constant. So don't you think I1 plus I2 should be a constant? And instead of writing I1 plus I2, it is actually I plus E. Am I right?
Yes, ma'am. Yes.
I1
Correct.
plus E. That I2 is actually not angle of incidence, it's the angle of emergence after the second refraction.
Yeah, the diagram.
In the diagram, this I2 is actually the angle of emergence.
Emergence,
It's not angle of incidence, right? Fine. So now I plus E should be a constant according to this equation because A plus D is a constant.
So I1 and I2 are interchangeable.
If I becomes E, E will become I. Adana max set. See, 5 plus 10 is equal to, if I say A plus D, I give some value. Right? Say A is 60. Number
60 plus
A
40,
60
let us
plus
say.
40. So I should get 100. So maybe I
So
is
if it is
40
na, sorry, 50 na, this will
50
be.
na, that will become.
Sorry, 50 podala. I1 45
ma'am. 45.
45 na, this will be 55.
If I becomes 55, E will become 45, correct?
So here on the I 45, E 55. Suppose I becomes 55 na, E will become 40.
E will become, E has to become 45.
45. So they are interchangeable.
They are interchangeable. Another way of explaining it is by principle of reversibility. Do we know principle of reversibility? Ma'am, just go back to the diagram. Maybe if I can take a minute. Yeah.
Take
so
a
in
mirror.
this diagram, teachers, see you have the first refraction. Beautifully, ma'am is drawing there. So you keep a plane mirror perpendicular to the emergent ray. What will happen to that ray? It will retrace its path, right? Any ray falling normally on any surface will retrace its path. Now, what does your E become? E has become I, right? And E becomes I, then I becomes E, correct? Are you getting teachers?
Yes, ma'am.
So this question is a board question. So you can either explain based on this equation A plus D is equal to I1 plus I2, or you can explain it based on the principle of reversibility of light. You say if
so you are, for that only graph is very much required.
So that is why the graph should be drawn, and the explanation for same D for two eyes is this.
Yeah, for same del, there are two angles of incidence, angle of deviation is the same.
Justify
so for that the graph is required.
Thank you, ma'am. You can
Yes.
proceed.
Yes, yes. So we derived this expression, this very important derivation. Mu is equal to sine A plus delta minimum by 2 by sine A by 2. So based on that, for thin prism, I don't know whether it is included, but you can tell the children how to get del value for thin prism. Del is equal to mu minus 1 into A. You also do this derivation, isn't it? For thin prism. We take that sine of sine I1, you take it as sine I as I. Sine A plus d by 2, we'll take it as A plus dm by 2 itself. So in that derivation, if you apply the prism formula, we'll get del is angle of deviation is mu minus 1 into A. So angle of deviation depends on, see, suppose from this we can explain dispersion. That is why you have to do this derivation. So here, when white light passes through the prism, which color get deviated most and which color get deviated the least? Which color?
Violet color will.
Violet color, yeah, violet color. So we draw like this. This is a spectrum. So this will be red and this will be violet. So the angle of deviation for red color is least and violet color is maximum. Because in this formula, del is directly proportional to mu. You know that just now we discussed this. Mu R is the refractive index of glass for red color is less than refractive index of glass for violet. So mu V being greater than mu R, deviation for violet, the different colors get deviated through different angles. Okay, and the deviation is maximum for violet color. Okay. So these problems are based on prism. You can go through it. I will send the PPT. This one I want to discuss. A ray PQ incident on face AB of a prism ABC as shown emerges from the face AC such that AQ is equal to QR. Draw the ray diagram showing the passage of the ray through the prism. So AQ is equal to QR means how the ray of light is traveling through the prism. AQ is equal to QR.
Parallel to the base of the prism.
Parallel to the base of the prism. So this deviation is del M. Minimum deviation. Only at minimum deviation, the ray of light will travel parallel to the base. So when it is traveling parallel to the base, what is the relation between angle of incidence and angle of emergence?
Same.
Same. So you have to calculate if the angle of the prism is 60 degree and refractive index of the material is given, you have to find out the angle of incidence and angle of deviation. So I plus E is equal to A plus del M. So angle of the prism is 60 degree. So you can write 2I is equal to 60 plus del M. So I can find out del M is equal to, and you can write sin I by sin R. The angle of incidence is given. Refractive index also given. So I can find out what is I, because all these values are given here. The angle of the prism is 60. How did I get I as 30 here? How did I get I is, see here, how to, at the angle of minimum deviation, R1 plus R2 is equal to A, isn't it? So 2R is equal to A. So R is equal to A by 2, that is 30 degree. So we know that ray of light is undergoing minimum deviation. At minimum deviation, R1 plus R2 is equal to A. So R is equal to A by 2. So now you have to find out angle of incidence. So sin I by sin R. Refractive index is given, isn't it? Refractive index is √3 given. So sin I is equal to √3 into sin 30. So sin I is √3 by 2. So I is 60 degree. That value also I got. Okay. So the children should understand this. From the first line is AQ is equal to QR. When the diagram, it's given that AQ is equal to QR. That means a ray of light is traveling parallel to the base. So it is a minimum deviation condition. Under minimum deviation, I is equal to E. So what are the values the children should find out? They have to find out what is angle of incidence and angle of deviation. So the first, under minimum deviation, R is equal to A by 2. So R, knowing the value of R, the child can find out what is I. So if I know I value again, this I plus E is equal to A plus del M. This formula the child should recall, and here I is equal to E again because it is minimum deviation. So 2I is equal to 60 plus del M. So from that, del M is 60 degree. So another repeatedly asked question is this one I want to do because before I end the session. Yeah. This one.
Yeah.
3 light rays, red, green, blue, orange. There's a most often asked question. Many times this question was asked, is it not, ma'am? The
Yes,
refractive
yes.
index of material of the prism for red, green, blue wavelength are respectively this. Trace the path of these rays, reasoning out of the difference in their behavior. So this angle is 45. That I should give. This angle is 45. Okay. So first of all, when a ray of light is incident, normal to PQ, we have to trace the path of light. Suppose this is the thing. So what is the angle of incidence here? This one is 45. What is angle of incidence? What is the angle of incidence for this ray? Can I draw a normal here? So I draw a normal.
Mark this upper, the other angle also is 45 now.
45.
Yes.
Yes. 45. This is 90. Now can I get the angle of this angle? Can I this angle?
There's a right triangle here.
The right angle. This is 45 now. This angle is it's a normal. So full angle is 90. So what is angle I? Angle I is 45. So now actually we should prove in this what whether which ray will undergo total internal reflection, which ray will pass through. Okay. So what is the condition for total internal reflection? What is the condition? Angle of incidence should be greater than critical angle.
I see.
Correct? So sin I follow this method only. Sin IC. What is sin I? 45. Greater than. What is the relation between critical angle and refractive index? Correct? Sin IC you can write it as 1 by n. So 1 by root 2 is greater than 1 by n. So what is the relation? For TIR to take place, what is the condition I am getting? 1 by root 2 greater than 1 by n. Apana n should be greater than root 2, correct? Am I correct? Yes. So refractive index of the prism for these 3 colors are given. So which color will undergo internal reflection? Only if the refractive index of the prism for a color is greater than root 2. So which color will undergo?
Blue and green.
Very good. Blue and green. Only for blue and green, n is greater than. So blue will undergo internal reflection. Green will undergo internal reflection. For red, it is only refraction. Okay. So sometimes what they do know, they try to find out the critical angle for blue-green using the formula. That becomes a very lengthy process. N is equal to 1 by sin IC. Sin IC is equal to 1 by n. So with the value of n, they find out IC, sin IC, then IC. So it involves a lot of calculations separately for blue, green, red. They have to find out. Then they have to check whether I is greater than IC. So better instruct the children to follow this step. So it is a one-step process. So I have given other problem also. You can consider this as a homework. Okay. So you are given the following 3 lenses. Which 2 lenses will you use as eyepiece and objective construct an astronomical telescope? Which one you will select? Power and aperture are given. I told you for telescope, objective aperture should be more or lesser. What did we discuss? So L1 should be objective because it has a large aperture. You should also consider focal length. Focal length magnification for telescope is f4 by fe minus. So f4 must be great. Power is given. So ask the children whether power is given or focal length is given. Power less power na more focal length. So among the 3 lenses, L1 has the Least
Objective.
power, so L1 should be objective. Eyepiece,
L3.
L3. Yeah. L1 objective, L3 eyepiece.